Hi, so this is going to be part 6 of my AeroSense IT/OT project, and in this part I'm going to explain how I have set up the feature engineering, train, inference, and evaluate pipelines. So here I've used polars, and this is the feature columns that we'll be working with, and this is taken from the goal dataset. So the risk levels, safe, warning, and critical, I've defined this upfront, so this will be the categorical values that we'll be trying to predict later on. So based on the battery, wind, and lidar warnings, which I've defined on the settings as risk threshold. Based on these values, we'll be assigning safe, warning, or critical flags on each row entries. And for the feature engineering or derived values, it's the absolute roll, pitch, and altitude, and rolling mean of battery and speed. So these are the derived values as well. So with this will be the final structure, and this will be what we are using for training and for predictions. In the training part, you can see that first I've imported the ML flow and then I've imported the two models. So this ML flow.xgboost and ML flow.sklearn, these are flavors, or these are helper functions for working with XGBoost and sklearn models. So I'll be creating two models, one with a random forest classifier and one with an XGBoost classifier. And I'm using label encoder for encoding and the train test split. So first I'm creating a session to connect to the gold telemetry dataset, and from there I'll be extracting the data, marking it as X for all the features and Y for the risk values. And this is where I've defined the random forest with the parameters. So basically I've run this separately, took the best parameters and added it on this code. And for XGBoost, I've done the same thing, added the parameters, and I've also added a code for class weights. So since random forest is a tree-based model, it can handle class imbalances. But when it comes to backend models, we need to address that separately. So that's why I've added the class weight separately. So in the main training cycle, so first we are doing the XY splits for train and test. This is the label encoding. We are calculating the class weights depending on the data that we have collected. And this is the loop where the training starts. So first we'll be logging the parameters, then the training, then we'll do the prediction, and we'll be logging these metrics as well. So for both random forest and for XGBoost, we are doing the same thing. And we'll be logging the artifacts, the bytest XSpread, as well as the metrics as well. So once this is done, we are using MLflow to check which of the two are the best model based on the F1 score, and we'll be logging that as the best model selected. So here we are using mlflow.startrun to register the best model, and we are logging that and moving on. So this last part, it's just to create an image of a confusion matrix based on the best model and just log it to MLflow. For the inference pipeline, first I've defined the prediction results, and I'm loading the model and making a prediction, and the prediction will be based on this structure that I've defined here. And for the evaluation pipeline, these are just again a little bit more calculated values and metrics that again I'll be logging onto MLflow. So here, the first time you run this project, uh, we'll first be collecting data from AeroSense. We'll be using that to train the model and to save the best model. And from the second time onwards, we can use the same model in order to predict the risk levels like safe, warning, or critical for the live streams. And with that, we can take action on either landing the drone or making any movements depending on how we set it up. So this is the ML part of my project, and in the next part, I'll be explaining how I have containerized this whole project. Okay, so that's it for this part, and thank you.